Hi, in this video we're going to talk about how to solve absolute value inequalities that have single absolute value expression. So what we are going to do is we're going to take a look at these couple simple examples first. So what does it mean when x is less than or equal to 4 in example 1? Remember, x absolute value represents the distance between the number and the number line and 0. So if you want the distance between 0 and the number to be less than or equal to 4, look at this. If I go 4 units this way, or if I go 4 units this way and no farther than that, then I'm going to be fine. So I'm actually going to be right there if I want to do it graphically, okay? But how do you do it algebraically? When you have an inequality with absolute value that has the sign pointing towards that, that means it's going to be x is less than or equal to 4 and x is greater than or equal to, and you change the sign here, -4. Okay, and that's exactly what we got here. So if you write it as an interval, it's going to be from -4 to 4, and we are done. Let's take a look at the next one. What does it mean that x has to be, the absolute value of x has to be greater than 6? That means you have to be farther than 6 units away from 0. So you're going to start from here and go to the right. And you can also go this way, and from -6 go to the left. What does it look like when you do it algebraically? If it's greater than, then it's going to be x is greater than 6. It's going to be or x is less than, and you change the sign, -6. So that's what you get. In this case, you have two inequalities that connected with or. You consider the two intervals together, so it's from -infinity to -6, open since it's greater than, and we're going to combine it from 6 to infinity. So it's a very basic idea behind it. Now let's take a look at some more examples. Solve this inequality. First of all, the sign points towards the absolute value sign, so it's going to be and. So we're going to have 2x minus 1 less than 3 and 2x minus 1 is greater than, and you do the opposite. So this has 2x is less than 4, which gives you x is less than 2. And here we're going to have 2x is greater than -2. Which means x is greater than -1. So we want x to be greater than -1 and at the same time less than 2. It's going to be from -1 to 2, and we are done. This next inequality, the sign points away. So we're going to do x plus 2 is greater than or equal to 5, or when it's away, it's or x plus 2 is going to be less than or equal to -5. So this gives us x is greater than or equal to 3. This one gives us x is less than or equal to -7. Okay, so one number is an or. Numbers are going to be either greater than 3 or less than -7. So we're going to have -infinity to -7, closed because it's greater than or equal to, or less than or equal to, united with closed from 3 to infinity. Okay. All right. Let's take a look at a few more examples. This one here is going to be 3. First of all, we want to isolate the absolute value sign. So if it's not alone, we need to take care of this number 3. So what we do is we subtract 3, and we get 3x, absolute value of 3x minus 1 is greater than -2. Should you continue here? The answer is no. Why? Because the absolute value, as we know, is going to have to be a positive quantity, or 0. This says here that something that's not negative is greater than -2. Well, anything that's not negative is always going to be greater than the negative value. So that's going to be true all the time. You should not even write any work here because you're going to spend time for no reason. So what can we say? The answer here is going to be all real numbers. Any value of x is going to make this inequality true. Okay? Next problem. So we're going to get rid of that 4. And this one comes out to be a little different. For absolute value of 4x minus 3 is less than or equal to 0. Well, we just talked about this. We know that the absolute value can be 0 or positive. And in this case, we got an absolute value that's going to be either 0 or negative. Well, we certainly know it can be negative. So really the only thing that's going to make this work is going to be that it's going to equal 0, which gives you x equals 3/4. And this is the only solution that this inequality is going to have. It cannot have anything else because you cannot make this absolute value negative. You cannot make any absolute value negative. Sometimes you have a variable involved. Well, if a variable is involved, are you doing anything different? Not at all. You're going to handle it the same way. So, the absolute value of 2x minus 1 is less than or equal to x plus 2. Less than is going to have and. So 2x minus 1 is going to be less than or equal to x plus 2. And we also want for 2x minus 1 to be greater than or equal to the opposite of x minus 2. I'm sorry, x plus 2. I didn't write it very good. 2x minus 1 is greater than or equal to the opposite of x plus 2. So when we solve each one of these inequalities, this inequality here is going to give you x is less than or equal to 3. This inequality here is going to give you x is greater than or equal to negative 1/3. So less than or equal to 3 and greater than or equal to negative 1/3. We're going to go from negative 1/3 to 3 and we are done. Okay. Next one. We need to isolate the absolute value first. So take away 5. You're going to get the absolute value of x plus 1 is greater than 3x minus 5. So now we're ready to do it. The sign points away from the absolute value, so we're going to use or. So we're going to have x plus 1 greater than 3x minus 5. Or we're going to have x plus 1 is less than negative quantity 3x minus 5. Now we solve each inequality together. This inequality here is going to give you x is less than or equal to 3. In this inequality here, you are going to get that x is less than or equal, no, I'm sorry, that's just less than. This one is going to be less than or equal to 1. With or, two inequalities point in the same direction. With or means the larger one of the two will be used. So our final answer is going to be from negative infinity to 3. Okay. All right. Next example. Let's take a look at this. So here we have the absolute value of x plus 1 is less than x minus 1. So x plus 1 is less than x minus 1. Sign points towards the absolute value. It's going to be and. And here we're going to have x plus 1 is greater than negative x minus 1. So this inequality here is going to give you 1 is less than negative 1, which is actually not a false statement and it's going to have no solution. What about here? Well, when you do this, you're going to get x plus 1 greater than negative x plus 1, and you are going to get that 2x is greater than 0, which means x is greater than 0. Here's the problem. This solution here seems fine, but and does not allow you to have any solutions here because this has an empty set and you can add, and when you intersect an empty set with anything else, you're getting an empty set. So this equation here, the solution is going to be an empty set or no solution. How is the next problem different? Well, it's a good question. Is it different? The sign points the other way. So let's see how it's going to impact the answer. So we're going to have x plus 1 greater than x minus 1, or x plus 1 is going to be less than negative times x minus 1. This here gives you 1 is greater than negative 1, which is actually true. So it's going to be all real numbers for this inequality. What about the other one? Well, the other one's going to give us, the other inequality is going to give us 2x is less than 0, which is going to be x less than 0. But with or in between them, all real numbers is going to suffice, and that is going to be the answer, all real numbers. It's very important to understand here is how to solve compound inequalities, because when you have variables involved, and even without the variables, you need to know how to solve compound inequalities. Otherwise, some of these things may look like something pretty challenging. Okay, I have two more examples. Let's take a look at them. So the example 11, you got this inequality, the absolute value is by itself. So this is going to be 2x minus 3 is greater than 2 minus x. The sign points away, which means it's going to be or. It's going to be 2x minus 3 is less than, reverse the sign, put negative times 2 minus x. So this inequality here is going to be 3x is greater than 5, which means x is greater than 5/3. For the second inequality, we're going to get x is less than 1 when we simplify all that. And we have or, which means we're going to have to combine them together. So you want x to be less than 1, or you want x to be greater than 5/3. 5/3 is greater than 1. So our solution is going to be from negative infinity to 1. And we're going to unite it, and it's going to go from 5/3 to infinity. Okay. And our last example, this problem. The absolute value is by itself, so we're going to write 3x minus 4 is less than negative x plus 6, and because it's the sign points towards the absolute value, 3x minus 4 is going to be greater than negative times negative x plus 6. So this inequality here, when you solve, it's going to give you 4x is less than 10, which means x is less than 5/2. This inequality here will be 3x minus 4 is greater than x minus 6, which is going to be 2x is greater than negative 2, which is going to be x is greater than negative 1. So you want x to be greater than negative 1, yet less than 5/2. And the solution here is going to be from negative 1 to 5/2. And that's it. And I hope this helps.